Okay, today we have replacement class. B503 classroom, 4 to 5. Next week also same. Okay, now we have covered chapter 1, chapter 2. By now, just a knowledge check or review. You should able to do vector. You should able to do dot vector. A dot B equal to AB cos theta. You should able to do AB also equal to AX BX plus AY by plus az bz. You should able to do free body diagram where you can do in 2D and 3D. 2D, you should able to split your vector into fx, fy with the theta. 3D, you should able to write your vector f equal to f mu, not mu, f multiplied by un, direction vector. How to get this one? You need to get the r. Okay. Okay. So these are the things that you should know. In chapter 3, you already start with equation of equilibrium, where is all the force equals 0. You can split into all the force. Okay, all the force into 0. You can apply to 2D and 3D. Okay, so if 2D, you only have all the force in x or y or z in equal 0. But in 3D, you need to do 3 more equations. Okay, all the force in x equals 0, equal y 0, z 0. And here you should also know how to find alpha, beta, gamma in 3D. Yeah, so basically by now you should already know all these things. Skill needed for this one is your cosine rules. Cosine rules, if you're given a non-right angled triangular in a parallelogram, you should able to do cosine rules. Or you're given right angled triangular, you should able to do tangent sine cos. Okay, so if you're weak in trigonometry, you're weak in cosine, or you're weak in multiplication of I multiply I, J multiply J, or I multiply K. If you're weak, you need to go and practice. So we already covered this one, and we assume you already seen you already go and practice all the tutorial question, right? So I already asked you go and see all the tutorial question. Some tutorial question that not discussed in class, but in my slides, they are quite tricky. So go and see, go and have a look in all these tutorial question. Today we go into chapter 3, which will be still equilibrium of equation, which will be come out in your test 1. The test 1 will be after Chinese New Year break. Okay. Today we were still in equation of equilibrium. Previously, all the force equals 0. Today we'll look in another one, all the moment equal 0. Okay, all the moment equals 0. Just to recap, if you already forget what is moment is the twisting motion. Okay, twisting motion. So how do you turn a thing? You need a force with a distance, then you can turn the thing. Okay. Let's say this is your reference point, O. And there's a force. This is a force. The force with the distance perpendicular, this is the D, perpendicular distance. The products of these two, F multiplied by D, will give you a moment around the reference O. Okay, and we label as M. M sub O means moment at point O. Okay, conventionally for moment, we will use right hand rules. What I mean by right hand rules, your finger curve in this way, right? So conventionally, we will do anti-clockwise positive for moment. Okay, so for moment, conventionally, when you solve question, your direction is important. You look at your right hand, your hand curve in this direction, so it's anti-clockwise. Your finger means the axis direction. So if you look at the diagram that I draw on the whiteboard, if this moment clockwise, it means you need to flip your finger, your hand. So the direction is going inside whiteboard. Huh? The axis O is inside the whiteboard. So if you draw in 3D, 2D you already know, X, Y, and Z. So conventionally, you use right-hand rules. X-axis, you curve like this, right? So x-axis moment will be this way. This is mx. Y will be using your right-hand rule also. It will be anti-clockwise my. For Z, also same. Your finger curve, it will be anti-clockwise mz. If you understand 3D, you can do 2D, same. Okay. If it's 2D, you only need to answer either the axis going out from the paper or going into the paper or going into the whiteboard. Okay, by seeing your right hand finger, your thumb. Okay, if you understand this one, basically we already can summarize chapter 3. The rest is just exercise. Okay, now one important thing for moment is what? Your moment vector and the distance must be perpendicular. Your force and this D, the distance from a reference point, they must be 90 degrees. If not 90 degree, moment doesn't works. It must be 90 degree. So when you draw on your free body diagram, make sure every time you need to find a D. This is a thing that missing in the question most of the time. You need to find a D. So make sure the D that you find always 90 degree to the force. So you need to draw a line that show 90 degree. And then you calculate lah, by trigonometry or by cosine rules, you find a D. D and F, it will form because the force is to the right. So it's like putting a string and you pull in this direction. So it will turn clockwise, like what I've drawn on the whiteboard. So if the arrow pointing another side, it will be anti-clockwise. But again, right hand rules. You right hand rules. Okay, so if you understand this one, basically we already conclude chapter 3 already. All right. So here, if you see this diagram, still same. If you have a force with the D force perpendicular to the distance from the reference point, it will form a moment. So it's like you are unscrewing the nut, the nut or screw. You do this way, right? So you know that conventional screw, you lock is anti-clockwise. If you want to lock a nut, Not now. Clockwise is lock. Anti-clockwise is unlock. This is international standard. Okay. So here you see the blue color circle, also right hand rules. Okay. So because the force is swinging this way, so your fingernails, they are the direction of the force. Right? You put here direction of force, so it's pointing up positive, Z positive. This is the axis or direction of the moment. Okay. So the rest you read. The rest you read. What is the unit of moment? What's the unit? How you get moment? Moment equal to force multiplied by distance. What is the unit of force? Newton. What is the unit of D? Meter. So it's in Newton meter. So you will see the answer that we will write later will be Newton dot meter. It's good to practice statics with the dot in your answer. Why? If you write N, M, it might become prefix already. It can be something N, right? Okay. So if force is not applied at 90 degree, remember to use the trigonometries. You still need to find the force that is perpendicular to the force. In this one, we assume perpendicular. You see this one got a square here, the left-hand diagram. This is 90 degree. If the degree here is not 90 degree, you need to find the angle, the distance that is 90 degree. Okay, so you don't use the wrong D. You use the wrong D, you get the wrong answer of moment. Okay, these are the careless mistakes. So, and also usually these are the trick that you see in the question for test 1, test 2, and final exam. So don't be tricked by this one. Okay, you're always finding the D that is perpendicular to the force. If you confuse, you just extend the force line. You use a ruler, draw a force as long as you can. Then you use your ruler. Your ruler is 90 degree one. You put your ruler edge to that line and connect with the center point or focus point. Okay, then you draw a line, you get that D. Label D dash as your additional distance. This is the question D. If you need to put another D, you can either use D comma or D1, D2, D3. Label carefully. Label carefully. And if the question give you F, don't go and change the F in your solution. If the question give you F, don't go and change P, Q. I will circle and question where is P in the question. Right? Okay. So this is just application. So if the D and force is not perpendicular, when you apply in a daily life, you'll feel you need to push more force to turn the nut. Okay. So if it's not, it means that the way you push is not 90 degree. You will feel a bit hard to turn because the formula become F D sine theta. Okay, F sine theta and FD is different. So you need more force to push the thing. Okay, so in the work safety OSHA, so every time you work with something, there's a SOP. So when you turn things, make sure you turn in the 90 degree. Don't push from somewhere. So it will make the things harder. Okay. So another thing, this is 90 degree on the left. The one on the right, very stupid question. Were you able to turn the board? No. Why? You only have pulling motion. Okay. So it just means for moment to happen, it must be 90 degree. If the force is following the axis there's no moment happen. Okay, so how these two diagrams help you in the test? Okay, let's say I copy the wedge. Okay, I copy exactly. Let's say you have a force that pulling this way. Force. So what do? You every time you see an angle, you need to split the force into the axis, right? So you can build your axis. If this force is a certain angle, you can put y and x if you want. So every time you see a force with the angle or vector with the angle, you need to split into y and x. So fx equal to cos theta, f cos theta. This is f sine theta. Okay. So this one, you can see, this one is 90 degree. Fy can form moment. However, fx cannot form moment. So every time you see force that have angle, remember to split into x and y or 90 degree thing. So you spread your left hand or right hand, never mind. You spread your 3 fingers. You know that you can split into x and y. Okay. So just remember this. So yeah. So force perpendicular with distance will create moment. Force that go align with the axis will not create moment. It will just create tension to the bodies. Okay, and you know that forces can be moving. It can be moving, but later in the later chapter. Now our force is on the axis. On the axis. Later in later chapter, you will see we are moving the force somewhere, and it will create some reaction. Okay. Okay. The rest you read. Okay. Okay. Or you can understand as force, if it go parallel with the axis, what happened to the D? D will be 0. So that's why moment equals 0. If you can understand like that. Okay, because your moment equal to F multiplied by perpendicular distance or force perpendicular to the distance. So if you move your force perpendicular to the axis, your D will be 0. Okay, this D is 0. Yeah, the D is 0. Okay, the D is not the 2 point. The D is from the force to the reference point. The force to the reference point. It's not the distance between the hand and the circle. It's the distance between the force and the reference point. It's not the object distance. Don't confuse with this diagram. Okay, if you understand this one, we'll go fast a little bit. By looking at this diagram, you know the sense of rotation. This is just to introduce you the right hand rules. So if the object moving in the circular motion, the force will always tangent to the curve. So tangent to the curve, most of the time, if there's a force, then it will turn. Okay, it will turn. So this is 3-dimensional illustration. Normally, you see this one in the question, but when you solve question, this will be the one that we expect to see in your solution, in your answer, right? So what you do, you draw a circle and you draw the force. With the circle always perpendicular to the center if you have a circular motion. Remember that, Okay. Now, you know that moment is a vector. Vector have magnitude and direction. So how to find magnitude? Magnitude is the formula that you take F multiplied by D. Again, these two must be perpendicular. These two, either this one must be perpendicular to each other. Okay. Okay, D is moment arm. The textbook name for the D is not distant, it's called moment arm. So sometimes the question asks you to find D. So the question won't mention D, it will mention the calculate the moment arm for the moment created in the system. So you need to find the D. Okay, unit is Newton dot meter. Direction is your thumb. Direction is your thumb. So direction is the moment axis, which is represented by your right hand rule's thumb. Okay, which is perpendicular to the plane. What is the plane? So let's say you have a A4 paper. Force and D are happening on the piece of paper. So it depends on the direction of the force. So if it's anti-clockwise, then it's pointing out. The axis pointing out 90 degree to the surface of paper. You like that? This is what this means. Okay, always 90 degree to the plane of motion. Okay. Now, once you understand this one, we are now the previous slide is all one moment, one force. One force with distance, we create one moment. So what happens if you have many force? If you have many force, you have three different moments. Okay, fixed at the focus point O here. So you should understand F1 multiplied by D1, you get moment 1. So you just write MO1 because it refers to center O. And this one created by force number 1. So you write M sub O1. The direction following the right hand rules, M1 will be coming out from the screen. Magnitude, what is the magnitude of moment 1? F multiplied by D. Clockwise, sorry, anti-clockwise. So it will create positive moment. Moment 2 created by F2D2. So write MO sub 2. And the direction will be going inside the screen. So this one form clockwise, so it become negative moment. Okay. So we assume X, Y, something come up from the screen become positive. Right? X moving to the right positive, go up positive, coming up from the screen positive. Same with number 3. Number 3, you will create moment when you have a force multiplied by perpendicular distance. So this one will be anti-clockwise, positive, coming up from the screen. Coming from the screen from where? From O. Okay, from O. So location is important now. Not anyhow put one location for the axis. It's important. Okay, so if you understand, since we are studying the equilibrium means the system is stable. Stable means if you put the thing on the table, it won't spin, it won't rotate, but there's a force acting. So all the moment you combine become 0. Means you write this equation, anti-clockwise positive, all the moment equals 0. So you write all the moment. Okay, all the moment you take for example this diagram, you write MO1 plus MO2 plus MO3 equals 0. Then you substitute M1 negative MO1, or you write negative F1D1 plus positive F2D2, then negative F3D3 equal 0. Then you find the missing forces or distance. Okay, now write this one from today. From today, in your test 1, start with direction, positive, anti-clockwise, M resultant or M usually you write MR resultant at what? In this one it's O, but if the question give you not O, give you A, then you write A here. Right, A equal sum of F multiply D. Okay. Like this. Once you write these steps, you write these steps. Okay, so it apply for the same for the chapter 2, force. So before you write something, write direction first. Force, go up, you write positive, go point up, then force, all the force equals 0. All the force in Y 0 or X 0. Okay. Then the next steps is just expand what you mean. Okay. Okay, we now look at one principle or general rules for moment. It's called Varigon theorem. But anyway, this name is not important. This one you read. Moment of the force about a point with its Fd equal to the sum of moment of the component of the force about the point. So this is, we already explained since the beginning. It's just stretching the position of the force and the distance. So if you have a blue color force somewhere in the space, this force must refer to the one reference point. In this case is O. Okay, so if you are seeing one forces with reference O, you'll be given X and Y for the tail. First step is to split the forces into X and Y. For this module, always, when the first step, always draw something, diagram. So if you see forces, remember to split into two components, Y and X, or Y or Z, depending on the question. Okay, so this one is Y and X. So you split. When you split already, you can see how the moment create already. Okay, now about moment O. Okay, the total moment will be the blue color multiplied by the D, the total moment, because the blue color is the resultant force. Multiplied by the D, you get moment. However, this force can split into two directions. One is parallel, Fx, multiplied by perpendicular distance, which is your Y, this Y, create moment. This one, Fy, if you multiply by X, it will also create moment. So moment 1 created by force X plus moment created by Fy is a sum of moment created by the blue line multiplied by the D. So there are two small components, two small moments, you combine become resultant moment. Okay, now what is the difference between this diagram and the one that I draw on here? Like just now, when we pull at this axis, is when your D is 0. Meaning if I pull my forces, if I pull the end of my forces here, I put here. If I pull my force, I put here. I put the tail of this blue color arrow, the tail I put O. Then your Fx becomes 0. The moment created by Fx is 0. Because distance is D is 0. But there's a moment created by Fy. Depend. No, if you put Fy over here also, there will be no moment actually. If you pull your blue color arrow in O, you split in X and Y, the D both will be 0, no moment. So just to get an idea lah, every time force there is a perpendicular distance, it will create moment, but there is no distance, then no moment. Okay. So this is the meaning of this statement by Varigon theorem. So just remember, forces can split into two directions. It will create moment. This is 2D. What about 3D? 3D, you need to add one more X. One more Z, direction. Okay. Okay, application moment will always link with the rotation. Anything that can rotate in the rotation motion. So this one is twisting, like you turning this wheel. So this F is a resultant force. So you can split this resultant force into two components. Okay, into two components. One is this direction, one is this direction. You can transfer this one to here, this one to here. It's the same because this one pointing to one point, so you can split like that. Okay. So and the R from the distance here will be forces Fy and Fx. Fx doesn't create anything. Fx just pressing the object. Okay. Now this also tell you when you want to rotate something, if you're trying to extend your D, you're going to create a greater moment. If you watch the MacGyver movies or any science venture movie, they try to break something, they will extend the thing and then try to rotate the thing. It's because they are using very fundamental sign, which is using moment. F multiplied by D will create moment. So if you want to create a greater moment with the same force, let's say you are very weak, your hand is not very strong. You want to create greater moment, you extend your D, no? You extend this pull, the last pull. So that's why in the old days, old cars, Second World War, you see the old truck, their lorry steering is very big one. Why? Because that time don't have power steering. That old days they don't power steering doesn't exist yet. So they need to turn the big wheels of the big vehicle. So they need a big moment on the steering wheel. So nowadays all the sport car is very small because they already have the power steering. This is hydraulic system, another module already. Okay, so this one, the force will also created. If you refer to A, it will create moment at moment A. If you refer to B, it will refer moment created by B. Okay, just for info lah. So you need to be careful which do you refer to when you write moment equation. You refer to different point, you'll create different moment. So always have a good habit when you write all the force, the sub there, please write where do you refer to. That is a good habit. If not, you are confused. What do you refer to? Okay, if you stand here, no moment created. If you're standing right just below the force, no moment created because D equals 0. Okay. Okay. A quick exercise. Can you illustrate or find a moment for all these diagram? Can you do number 1? What is the moment at O? Will be what? How many? Moment at O will be 200 what? Newton meter. So if you write all the moment equal, and this one is what direction? What direction? Clockwise. So it's a negative moment. It's a negative moment. So for the first one, what do you do? Yeah. So this is just a 90 degree. Because I cannot find in Excel, there is a 90-degree symbol. So I just put this. Okay. So for the first one, the magnitude is 200 Newton meter. But if become vector, is a negative. If you assume is anti-clockwise. Okay. Don't confuse magnitude and the vector direction. Okay. So in this case, if you have a positive value, please give the positive direction. So if in front of you, you don't have any direction, please give direction at the back of the answer. So if you don't, if this one come out in test, you write 200 Newton meter without this one, I will not give you full marks. Because I don't know what direction of this. So for static or dynamics, we always look for magnitude and direction. So if you miss out this direction, then too bad lah. We have to minus mark. Yes. Yes. If you write positive anti-clockwise like that, all the moment equal like this. Of course, this one you can write equal to F D, and this one will be negative. So you multiply force 200 minus 200 multiply 2 equal to, okay, when you do calculation, maybe if you forget to put unit, I still give you correct. But the final answer, please give 3 significant figure and with the unit. Okay. Can you do number? Maybe this one too simple for you. Maybe can you do this one? Can you do C? What is the moment created in diagram number C? It will be. So again, you are seeing angle. Remember to split the forces into angle, into 2 forces. Or in this case, the forces, you don't need to split, you only need to calculate the distance. As long as F and D, they are perpendicular. In this case, if you split the force into X and Y, also doesn't help. So this one, because the force is going this way, so the perpendicular distance is here, O to this force. So you need to calculate 2 cos 30 plus 4 multiplied by 400, you get the moment. And this one will be anti-clockwise. Direction will be coming out from the screen. Sorry. Going into the screen, negative. Make sense? Can? Okay, so the rest you can check for your homework if you already understand. So I don't want to waste your time here. Any questions so far? No. So this one too easy because only have one force. We go into more challenging one. I give you more forces. Okay, again, just remember to give me the direction of the positive value or positive moment. Okay, this one may be too easy for you. Okay, so how to solve this one to create, to calculate the moment? So this one only have one force. So first steps, draw the free body diagram. Free body diagram means what? You remove the wall and you draw the outer shape of this object. Okay, then draw the dimension, put in the dimension, label correctly. O is here. So you say moment about O, so you're referring to here. So you're seeing force with the angle. So automatically split this one into X and Y. Here you don't see X and Y axis, you can create your own axis. Just extend this line, put as X, extend this one is Y, means going down positive. It doesn't matter. If you want to Y positive also can. Okay, but it's good that later you see a lot of false one. It's good that you stick at one direction, which is all the direction to the right is positive, all the direction going up is positive. Because you need to solve two equations, which is all the force equals 0, all the moment equals 0. So you stick with one axis. Don't change. Sometime go up, sometime go down. Huh? No. Okay, so this one you split into this one. F in x direction or going right is what? F what? Sine or cos? Sine. Huh? This one split to here, sine. This one cos. Huh? So both create moment. Huh? Both create moment. F, this one, go down, multiply by this one, will give you clockwise direction. Then this one will give you anti-clockwise direction. So you have a positive, negative direction. Huh? So how to write properly? So split the forces. Then when you start to write, please give this one. Positive, anti-clockwise, moment O, moment sub O, because the question asks you to find O, equal positive, this one give you positive, sign give you positive. Sorry. It should be negative. Okay, it should be negative. I think my direction is wrong. Okay, because F sine 40 will give you clockwise, and my notation here is anti-clockwise positive. So this one should be negative. This one should be positive. Yeah. No, no. You see from O. You refer to O. If you tie a rope, what happened? This one will twist like this. You tie a rope from here to or to here. This you extend. Forces you extend. The force will twist like this. It will twist anti-clockwise, clockwise. So there's a typo error in my slides because I assume anti-clockwise positive. There's an error in my slides. Yeah. Not necessary. Not necessary. Because you can split this force into x and y axis. But the total will be following the resultant direction. Because you are having resultant equal to small moment, two small moment. You combine, you get resultant moment. You understand? No. O and one forces here. When you split forces, this one cancel. When you split forces into Fx, Fy, don't go and see the resultant anymore. There's no more resultant when you split. So you might confuse because you still seeing this one. No, there's no more resultant if you split already. Okay, don't confuse this one. When you split, you are seeing two forces. These two will give you the answer for the moment. So this one, Fx, you turn like this one. Right? Then this one will turn like this one. And you decide which one will be positive. Conventionally, anti-clockwise positive. Conventionally. Okay, so you write all the force, all the moment at O positive where. So it combine with two moments. There are two small moments here. You take this one plus this one. So in calculation, you need to put positive or negative lah, depend on the direction of the one that you mark in your answer. If you want to mark clockwise, also can, no problem. Yeah. There are some typo error in my slide here. Typo error in my slides. You calculate lah. You calculate. I think the value also wrong. The first one, the sign one, create. Sign one, create. Sorry. Hey, correct. Sorry, correct. Correct. Because this one refer to here. 400 sign multiplied by this distance. Correct. Sorry. Correct. Positive. Correct. Okay. Then this one is for 0.4, distance 0.4. It's from here. It's clockwise. Yeah. Okay. I was so confused. Right. Okay. So this one is how we do lah. This is 1/4. You won't see 1/4 in your test or final exam. Okay. So I want to give you advice here. In calculation, if you get negative, maintain negative. This is just to tell you, section C, what is the real direction of the moment. So you need to interpret this one into the real direction. So negative, if you see negative, but your label here is anti-clockwise, negative means opposite from your direction. It become clockwise direction. Yes, no need. If you draw something direction already, you get some value. You don't need to draw the direction already. Unless you see this one, the one that I highlight. This one. This one I don't have direction in front. I put at the back. Okay. Okay, this one your homework. Go and have a look. Have a look. If you have question, come and see me. This is just to practice your trigonometry. This is 1/4. So this one got D here and D here. So these are this question got, I think, got more than 2 approach. You can put the force to X, to this direction and this direction. Okay, or you can put this one. You can put, okay, this one got distance, so you can here at 90 degree. Or you can put, you can do vector if you want. So there are some solution inside here. Go home and have a look at example 3. Okay. So got solution 1. Solution 1 is using this. You split into here and here, but there will be more. So meaning you are using different D lah. You're using different D. Okay. Solution 2 split into 45. So there are 2 methods lah. It depends on what you want. You still get the same answer. Okay. Now only the way you write, please be careful. Typically will be anti-clockwise. Sub O means from O. So remember, labeling is important. And once you get negative, remain there. And if the question gives you kilonewton, please use back kilonewton. This will be the careless mistake. Okay. Then only if the question asks you what is the real direction of the moment, you look at the question, look at the way you write one more time in the positive form and write the correct direction. Okay. In the exam, if the question didn't ask you anything, just ask you to solve, you stop at here, also correct. As long as you give the direction in your solution. Okay. And just a reminder, when you solve question, don't jump here and there in your paper. don't write M here, then you do some small calculation here, then suddenly jump back here and draw arrow here. Or you write, then you draw an arrow next page. Don't write this one. Just if you want to solve in the same page and from the top to bottom. Don't jump left, right, and then I need to find answer for you. Okay. You can even do the calculation by on the diagram, just anywhere near the diagram is also can one. Okay. All right. Solution 3, this one you can have a look. Okay. Okay, there are some exercise if you want to go, you can do. All right. So this will be your test 1 format lah. It's something like this, got 3 forces, all right? Something like that. Okay. Okay. We will do cross products in the replacement class later. So we stop here. So if you have any question on the moment, you can come and ask me. All right. So we see you 4 o'clock later.